we are going to study electric flux. What is the meaning of electric flux? Dear students, here you are observing these are equally spaced electric field lines. Both are. Here electric field lines are equally spaced. Hence, this figure represents uniform electric field. Okay. Now, we are going to study electric flux. Let us study what is the meaning of electric flux. See here, in this uniform electric field, I will consider a surface like this. Here, what I have considered? I have placed a surface in a uniform electric field. Let delta S be the area of this surface. Getting the idea? Now, already you know that this is the basic knowledge. What is the area vector of this surface? The area vector of this surface is always perpendicular to the surface. That is normal to the surface. That is, this is the area vector. Getting the idea? This is called what? Area vector. Shall I write it as delta S vector? This is the basic knowledge. The area vector of any surface is always normal to the surface. Here, electric field is also a vector quantity. Getting the idea? Here, area vector of this surface and electric field vector, that is vector E and vector delta S, both are acting along same direction. That means vector E and delta S vector both are parallel to each other. Okay, now our question is, what is the meaning of electric flux? Electric flux means when you place any surface in the region of electric field, then how many electric field lines are passing normally through each unit area of this surface. That gives electric flux. Getting the idea? Now, what is the meaning of electric flux? The number of electric field lines passing normally through each unit area of this surface is called what? Electric flux. My dear students, here we can't count how many number of electric field lines, 1, 2, 3, 4, 5. Why we can't count? Because electric field lines are invisible. Okay, that's why there is a way to find the electric flux, to find the total number of lines of force passing through this area. What is that alternate way? See here, if you multiply electric field in which the surface is placed and the total surface area of this surface, if you multiply these two, you will get what? Electric flux. That is total number of lines of force passing through the area. If you multiply electric field in which the surface is placed and delta S, that is area of this surface, if you multiply these two physical quantities, definitely you will get number of electric field lines passing through this area, which gives electric flux. Getting the idea? This is the way how we should find the electric flux. Getting the idea? And also you must remember, here electric field is a vector quantity and area vector is also a vector quantity. Area is also a vector quantity, electric field is also a vector quantity. Here, if you multiply these two, you will get the flux, which is scalar quantity. That's why dot product of electric field and area vector gives electric flux. Getting the idea? What is the SI unit of flux? SI unit of flux is Newton meter square per coulomb. Getting the idea? This is vector form. Okay. And what is the magnitude of this one? Here, where delta S implies what? Area vector. Its magnitude is delta S. Here delta S represents magnitude. And I will write n cap here. N cap, it is the unit vector along the direction of area vector. That is, n cap is the unit vector normal to the surface. Both are same. this is about electric flux. My dear students, here one more thing. Here also I have considered uniform electric field. Now in this electric field I am going to consider a surface whose area is again delta S. Getting the idea? And the area vector of this surface is in this direction. That is delta S vector. Because area vector is always perpendicular to normal to the surface. Getting the idea? Here electric field is also a vector quantity. Here area vector of this surface is making an angle theta with the electric field vector. In such cases, how we will find the total number of lines of force passing through this surface? Then we should find electric flux phi is equal to E into delta S into cos theta. Because I have already told you it is a dot product of E and delta S is nothing but flux. Since it is dot product, you will write cos theta here. Getting the idea? Now see here E is the electric field, delta S is the area of the surface, and theta is the angle between electric field vector and area vector. Okay, and this is the flux through the surface of area delta S. Now tell me, what is the meaning of electric flux? The total number of electric field lines passing normally through a unit area of the surface is called as electric flux. How it is measured? If you multiply the electric field surrounding the area and area of the surface, if you multiply these two, you will get the total number of field lines passing through the unit area of the surface, which is called as flux. SI unit of flux is Newton meter square per coulomb. Getting the idea? Now I will consider one spherical conductor here. Here there is a spherical conductor. Okay, and this spherical conductor is charged. Now let us find what is the flux of this spherical conductor. What are the total number of field lines passing through this spherical conductor? To calculate total electric flux across this spherical conductor, what we have to do? We have to divide the total surface area of this conductor into small area elements, each of area delta S. That is, this is delta S, this is delta S, this is delta S, this is delta S. In this way, you have to divide the total surface area of this conductor into small area elements, each of area delta S. Then summation of electric flux across each unit area, across each delta S, you must take. That gives total electric flux of this conductor. That is, in general, flux across this whole surface is given by summation of E into delta S into cos theta. This is the standard equation. Getting the idea? And one more thing here, if electric field vector is parallel to area vector, then what happens? Then theta is 0 degree. Therefore, flux is maximum into delta S, that is maximum. Getting the idea? And if electric field vector is perpendicular to area vector, then theta becomes 90 degree. Therefore, flux is equal to 0. Getting the idea? These two conditions are very important. And one more thing you should remember, that electric flux is not depending upon the size of the sphere. For example, if I consider this is a conductor of radius 5 meter, let flux on this conductor is 10 Newton meter square per coulomb. If I reduce the size of this sphere to the of radius 4 meter, then what is the flux? Here flux remains the same, that is 10 Newton meter square per coulomb. This means that whatever the size, flux will not going to change. Okay, that means flux is always measured the total lines of force, total field lines across each unit area. If you increase the size of the sphere or decrease the size of the sphere, the total number of lines of force across each unit area will not change. That's why flux is independent of size of the sphere. Keep it in mind. Getting the idea? This is about electric flux. Note down. Okay, my dear students, ಈಗಾಗಲೇ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿದೆ ಯಾವುದೇ ಒಂದು ಚಾರ್ಜ್ ಸರ್ಫೇಸ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಆ ಚಾರ್ಜ್ ಸರ್ಫೇಸ್ ದ ಪ್ರತಿ ಯೂನಿಟ್ ಏರಿಯಾ ಮುಖಾಂತರ ಎಷ್ಟು ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಹೊರಡ್ತಾ ಇವೆ ಅನ್ನೋದಕ್ಕೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? ಈಗ ನಾವು ಗಾಸ್ ಥಿಯರಮ್ ಅನ್ನ ನೋಡ್ತಾ ಇದೀವಿ. Already you know that when you multiply electric field surrounded by the surface and area of the surface, when you multiply these two physical quantities, you will get the flux. Here, one more alternate way is there to calculate the electric flux, which was invented by Gauss. That's why this law, this alternate way is known as Gauss theorem. Here, I will consider a spherical conductor. It is a charged spherical conductor. Okay, this is a charged spherical conductor. It is a closed surface of the earth. Okay, now what is the total flux of this charged spherical conductor, of this closed surface? That we are going to study. In the previous class, I have told you what if you want to calculate the total flux of this conductor, you have to divide the total surface area into small unit areas, each of area delta S. Then you have to take summation of electric flux across that delta S. Then it will give total flux. But here I am following different method. That is, in such cases we can calculate the flux like, according to Gauss, the total flux across this closed surface, which is placed in air medium, is always equal to 1 divided by epsilon naught into summation of Q. What it means? The total electric flux across this closed surface, which is placed in air medium, is always equal to 1 by epsilon naught times of total charge enclosed by this surface. This is called Gauss theorem. ನೋಡಿ, ಮುಂಚೆ ನಾವೇನ್ ಹೇಳ್ತಿದ್ವಿ, ಆ ಸರ್ಫೇಸ್ ಅದ ಈ ಟೋಟಲ್ ಸ್ಪೇರ್ ದ ಸರ್ಫೇಸ್ ಅನ್ನ ನಾವು ಸ್ಮಾಲ್ ಏರಿಯಾ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಒಂದೊಂದು ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಫ್ಲಕ್ಸ್ ಇದೆ ಅಂತ ಕಂಡುಹಿಡ್ಕೊಂಡು ಅದನ್ನ ಸಮೇಷನ್ ಮಾಡಿದ್ರೆ ಟೋಟಲ್ ಫ್ಲಕ್ಸ್ ಸಿಗತ್ತೆ ಅಂತ ಹೇಳಿದೆ. ಬಟ್ ಗಾಸ್ ಥಿಯರಮ್ ಮುಖಾಂತರ ನಾವು ಹಿಂಗು ಫ್ಲಕ್ಸ್ ಅನ್ನ ಕಂಡುಹಿಡಿಬಹುದು. ಈ ಗಾಸ್ ಥಿಯರಮ್ ಏನ್ ಹೇಳ್ತದ, ಈ ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್ ಇದ್ದಾಗ ಅದ್ರೊಳಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಇದೆ ಅದಕ್ಕ 1 by epsilon naught ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಬಿಟ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ಫ್ಲಕ್ಸ್, ಯು ವಿಲ್ ಗೆಟ್ ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್, ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದಿಸ್ ಸರ್ಫೇಸ್. This is Gauss theorem. Getting the idea? Here epsilon naught means what? This is the permittivity of free space. Summation of Q means what? This is the total charge enclosed by this surface. Getting the idea? Now see here, if this conductor is containing plus Q1 charge, minus Q2 charge, plus Q3 charge, minus Q4 charge. These are the charges enclosed by this closed surface. Now what is the flux of this surface? Now flux is equal to 1 by epsilon naught into total charge enclosed. Total charge enclosed by the surface. Getting the idea? If you multiply this with this, you will get the flux. Flux is equal to 1 by epsilon naught into what is the total charge enclosed by this surface? That is plus Q1 minus Q2 plus Q3 and minus Q4. This is total charge enclosed by the surface. Therefore, in general, flux is equal to 1 divided by epsilon naught into summation of Q. This is the Gauss theorem, called as equation 1. What is Gauss theorem? Gauss theorem states that the total electric flux across any closed surface placed in air medium is always equal to 1 by epsilon naught times of total charge enclosed by the surface. Here one more thing is there which is very important. When you are going to apply Gauss theorem, you can't apply Gauss theorem in all cases. There is a condition to apply the Gauss theorem. What are those conditions? See here, if you want to apply Gauss theorem, there are two conditions. First one is electric intensity should be equal at all points on the surface. Okay? And that electric intensity, that electric field, it should act normal to the surface. If these two conditions are satisfied, you can apply Gauss theorem. Okay, see here there is a spherical conductor. If the spherical conductor is charged, then charges are going to distribute uniformly over its outer surface. Since the charges are distributing uniformly, electric field at all points on this charged spherical conductor is same, and this electric field, this intensity acts normal to the surface. That is E. This is E. This is E. This is E. Getting the idea? At all points electric field is E only, and this field is acting normal to the surface. Getting the idea? Here, see here. At all points on this sphere, electric intensity, electric field is same, that is E, and this intensity, this field is acting normally to the surface of the conductor. If these two conditions are satisfied, then such surfaces are known as Gaussian surfaces. That is, to apply Gauss theorem, two conditions must be satisfied. First one is electric field at all points on the surface must be same, and second one is that electric field should act normal to the charged surface. Okay, note down. Okay, dear students, now I am going to prove the Gauss theorem. What I am going to prove now? Pi is equal to 1 by epsilon naught into summation of Q. That is, total flux across any closed surface in air is always equal to 1 by epsilon naught times of total charge enclosed by that surface. That is Gauss law. I am going to prove the Gauss theorem now. Okay. See here, now I will consider a spherical conductor here. Here I will consider a spherical conductor. Getting the idea? This is the spherical conductor of radius R. Here I have considered spherical conductor of radius R. Okay. Now small letter q be a charge which is placed at the center of the spherical conductor. Okay, that is sphere. Since I kept the q amount of charge at the center of the sphere, the electric field at any point on the surface of this sphere remains same, and that electric field acts normally to the surface of the sphere, that is in this direction. E, this is also E, and this is also E, and here also E. My dear friends, I have already told you the surface on which electric field is same and it should act along normal to the surface, then such surfaces are known as Gaussian surfaces. I already told you. Okay, hence this sphere, this shell is our Gaussian surface. Why it is considered so? Because at all points on this sphere electric field is same and it is acting normal to the surface. That's why it is our Gaussian sphere, Gaussian surface. Now let us prove Gauss theorem. Okay. Now electric intensity at any point on the surface of this sphere due to charge Q, which is kept at the center, is given by what? That is electric intensity or electric field due to electric field due to Q charge at any point on the sphere is electric field due to Q at any point on the sphere is E is equal to K into Q divided by R square. If concentration point is here, then distance between concentration point and Q charge is R, hence R square. Okay, here I will write R cap. R cap is the unit vector along the radius of the sphere. Okay, now called as equation 1. This is the electric field at any point on the surface of the Gaussian sphere. Okay, the point may be here, at all points this much electric field is there. Getting the idea? Now the total surface area of the Gaussian sphere is divided into small area elements. That is, let the total surface area of sphere, Gaussian sphere is divided into two small area elements. Each of area delta S. Then electric flux across each area is given by say, I will consider this is a small area of magnitude delta S. Okay, now here the total surface area of the sphere is divided into small area elements, each of area delta S. Then electric flux across each area element, each delta S, that is each delta S is given by what? That is delta phi is equal to vector E into area vector. Getting the idea? Called as equation 2. Now delta phi is equal to vector E value is K into Q divided by R square into R cap into what is the magnitude of area vector? That is delta S into n cap. Here n cap is the unit vector along the normal to this surface delta S. Getting the idea? And now delta phi electric flux across the area delta S, that is delta phi, is equal to K into Q divided by R square into delta S into R cap dot n cap. Getting the idea? Here R cap and n cap both are unit vectors and both are acting along same direction. Hence delta phi is equal to K into Q into delta S divided by R square into its value is 1. Getting the idea? Why its value is 1? R cap dot n cap can be written as R cap modulus dot n cap modulus into cos theta, because it is dot product. Since theta is 0 degree, its value is 1. Getting the idea? Called as equation 3. Now this is the total electric flux across the area delta S only. But we want what is the total electric flux across all delta S which are present in the Gaussian surface. This can be calculated by taking summation. Therefore, total electric flux, total electric flux across whole Gaussian surface, whole Gaussian sphere is what? Flux is equal to summation of delta phi. That is summation of electric flux across each area. Okay, each area elements. Now flux is equal to summation of delta phi is what? K into Q by R square into delta S, call it as equation 4. Now I will write okay, total flux across the Gaussian sphere is equal to K into Q divided by R square into summation of delta S. Getting the idea? Phi is equal to K value is 1 divided by 4 pi epsilon naught into Q divided by R square into summation of delta S means what? Area of whole Gaussian surface. That is, the total area of Gaussian surface is represented by summation of delta S. That is, total surface area of this Gaussian surface is 4 pi R square. Here 4 pi cancel, R square cancel, then pi is equal to 1 by epsilon naught into what is the total charge enclosed by the sphere, that is Q. Call it as equation 5. This is the proof of Gauss theorem. Okay, note down.